Hello everyone. So now it's time to revise the topics that you have already covered. So beginning with carbon and its compounds, the chapter begins with the types of bonds. There are two types of bonds, ionic that we have already studied in the previous chapters, that the compounds that are formed due to the bonds which are formed because of the give and take of electrons. For example, in sodium chloride, where the sodium ion and the chlorine ion combine to form sodium chloride when chlorine is getting electron from the sodium, right? So the another kind of bonding, the compounds that we have not studied so far are the covalent compounds. These are formed due to the sharing of electrons. Here give and take does not happen, only the sharing of electrons is happening. Okay, and so no ions are formed. The ions are formed only when the electrons are released or gained in a particular atom. So when no give and taker is taking place, so no ions are formed. Let's take the example of oxygen. Oxygen atomic number 8, where if I configure it, it will be 2 and 6. It will be needing 2 more electrons to form complete its octet. So if it combines with another oxygen which has a tendency to accept electrons, oxygen this oxygen also has a tendency to accept electrons, the other oxygen also has a tendency to accept the electrons. Now who will give them electrons? No one. So they adjust with each other by sharing their electrons. So the 6 electrons that the oxygen is having, 1 2 3 4 5 6, and the other oxygen that is having 1 2 3 4 5 6, 2 electrons from each of the oxygen are shared by both of them and thus satisfying both of them. Now coming to the differences between the ionic compounds and the covalent compounds. We have already studied that ionic compounds are formed due to the give and take of electrons, and the covalent compounds are formed due to the sharing of electrons. Because of this, the the compounds that are formed between the electron givers, that is the metals, and the electron acceptors, that is the non-metal. And the sharing happens when the two units are present which are not able to give the electrons, so they need to share it. That means the electron acceptors, that means the non-metals, combine with each other to form the covalent bonds. The solids, the ionic compounds are solids at room temperature. The covalent compounds can be of any state. They can be solid, they can be liquid, they can be gaseous at room temperature. The ionic compounds have high melting and boiling points, and covalent compounds have low melting and boiling points because of the forces of attraction that are present between their individual molecules. Ionic compounds are good conductor of electricity and heat because they can ionize in molten state. The covalent compounds are the poor conductors of heat and electricity. Now we'll see how the bonds are formed in the covalent molecules. Suppose we have hydrogen which is going to combine with another hydrogen. Both of them cannot give the electron to each other, they can share the electron. Hydrogen has one electron in its last shell, so does the other hydrogen also. So we will show the single electron that is there in the last shell and the other electron from the other hydrogen. 1 2, if these two are attached with the particular hydrogen to fulfill its K shell, these two are available for the other hydrogen also to fulfill its K shell needs. Okay, so when one pair of these are the two electrons which are being shared, two matlab we have one pair of electrons that are being shared. So we show this by this kind of single bond. Suppose two oxygens are going to combine with each other. We have 6 electrons for one oxygen, 6 for the other one. Both of them need two more electrons. So 2 from this oxygen will be shared by the other one, and 2 from this oxygen, this one, will be shared by this oxygen. With the circles, we show that it has completed its last shell. Okay, because here 4 electrons are being shared. 1 2 3 4 electrons are being shared. That means 2 pairs. एक इसका है, एक इसका है. ठीक है, this is one pair, this is another pair. So 2 pairs of electrons are being shared. So 2 bonds are formed. So we say that a double bond is being formed. Single, double or triple is associated with the same species. दो चीज़ों के बीच में जिसमें हम बॉन्ड स्टडी कर रहे हैं, तो उन्हीं के बीच में हम नंबर ऑफ बॉन्ड्स काउंट करते हैं, नॉट विद द अदर स्पीशीज. फॉर नाइट्रोजन it has 5 electrons in its last shell. It needs 3 more. So 5 we have shown, 1 2 3 4 5 for this nitrogen. We have shown 5 for the other nitrogen. Now the 3 electrons are to be shared by each one of them. Okay, that means the 3 pairs of electrons are being shared, and so the triple bond is being formed. If we see the example of a compound, अभी तक जो बन रहा था, what examples we have just seen now are all of the elements. Now suppose a compound has to be formed, that means we need 2 or more different elements that are combining. So we will be taking the elements which are not able to combine in ionic form. Suppose we have one carbon, so it has to combine with hydrogens. Carbon has 4 electrons in the last shell. Hydrogen has just 1 electron in its last shell. So in any case, one hydrogen will be able to satisfy only 1 electron of carbon. So it will be able to give only 1 electron to carbon, and carbon needs 4 more. 4 in the last shell and 4 more to complete its octet. Okay. So 1 hydrogen for 1, एक hydrogen 5, 6, 7, 8. So it is combining with 4 hydrogens to form 4 different single bonds. Let's now see how the carbon compounds are formed. Carbon has a tendency to form single, double or triple bonds with itself. So between carbon-carbon, we can observe single bond also. Between two carbons, we can observe double bond also. And between two carbons, we can observe triple bond also. So this is the basic nature of carbon, which is giving it so versatility in its compounds. Okay. So when only single bond is present, we call the carbon compounds as the saturated ones. We are focusing on the carbon compounds which are involving hydrogen, so we call it hydrocarbon. So with single bond, these are the saturated hydrocarbons. With double and triple bond, these are the unsaturated hydrocarbons. Okay. So if we see a single carbon, it cannot combine with any other carbon. We have just one available. It will combine with 4 hydrogens. Next, if we have one more carbon attached to it, so in a way we are replacing one hydrogen with another carbon. Now this carbon will also have 4 bonds. This carbon will be having 4 bonds. One bond is being shared. Okay, please do not put 2 different bonds between 2 carbons. One bond is shared. The electrons are shared, so one bond is formed, right? So if we have 2 carbons, we have 1 2 3 4 5 6 hydrogens. So we can say that the formula for the alkenes, general formula, if I ask you how many hydrogens does a chain of 10 carbons in alkanes will be having. So with this formula CnH2n plus 2, you will be able to reply that. Okay, in alkenes, we call the alkenes where double bonds are formed. Single C is not possible because we need at least two carbons to form a double bond. Okay, when a double bond is formed, there is loss of two hydrogens from each of the carbons. With single bond, we had placed the hydrogens here to satisfy the carbon bonds. Now the carbon is having two bonds in between each other, so it will not require any extra hydrogens. So with two carbons, we have 1, 2, 3, 4 hydrogens. With three carbons, 1, 2, 3, the double bond is formed only between any two of the carbons, not between all. Okay, so with two carbons, with double bond, we have 1, 2, 3, 4, 5, 6 hydrogens. That means the general formula for alkenes will be CnH2n. Now alkynes. Coming to alkynes, which are having triple bond between two C's. So any of the two carbons in the series will be having a triple bond, right? So when we have two carbons, we have two hydrogens. When we have three carbons, we have 1, 2, 3, 4 hydrogens, because the center C will not require any hydrogen as it is already completed its 4 bonds. We just need to see how many bonds carbon is forming. If it is forming 4 bonds, that means its valency is satisfied. So anywhere it has to be completed its octane by forming 4 bonds. So general formula for this will be CnH2n minus 2. Continuing with our chapter, carbon and its compounds, let's see again why carbon forms covalent bonds. Its valency is 4, and yes, it can gain 4 electrons to form an ion, but if it gains 4 electrons, that means it will be having 10 electrons. 6 पहले से थे and 4 और आ जाएंगे. It will be having 10 electrons. So it will be difficult for 6 protons to hold 10 electrons. Okay, suppose we assume that it can lose 4 electrons. अब क्या होगा? अब it will become C4 plus, but it will require huge amount of energy to remove 4 electrons from such a strong binding. So it goes for sharing. This sharing will give it a covalent bond with whichever material, whichever substance it is reacting with. Okay, so coming to the allotropes. Allotropes are carbon. Allotropes are the various forms of the same element which occur in different forms. The occurrence is different, they look different, their physical properties will be different, their chemical properties will be same because it is the same material. अगर कार्बन है तो केमिकली कार्बन जिसके साथ जैसे रिएक्ट करता है, diamond, graphite, fullerene, these are the 3 allotropes of carbon. They will behave in the same way chemically, but by looks, by other physical properties. Physical properties means their melting point, boiling point, conductivity, these all these things, या shine है, उनका nature है, behavior है, all these things will differ in graphite, in diamond, and in fullerene. Fullerene is a ball-like structure which is consisting of 60 carbons in a binded together, right? Graphite and diamond have kind of structure like this, where in diamond one carbon is tightly packed with 4 others, and in graphite one carbon is tightly packed with 3 other carbons. One is free. So एक तो this gives us a plate-like structure. This bond is weak, so it can break easily. Therefore, it is not very hard. Diamond is very hard because the intermolecular bonding is very strong. Also, uh, the freedom of carbon to move around and pass electricity. That's why graphite is a good conductor of electricity and diamond is not. It does not have free electrons to flow. Okay, the electrons are all occupied. Coming to the functional groups, uh, alkane, alkenes, and alkynes we have already done. If we replace one H with any other thing, that we call a functional group. If it is replaced by chlorine, bromine, fluorine, iodine, then we say the functional group is halogen. Halogens you have already studied in periodic table. Okay. Then we have alcohol group, which is OH group. So if one hydrogen, if I remove this hydrogen, it is replaced by OH. That means now it is a new compound which ends with all, but you don't have the nomenclature in your course, so you should just know the functional groups. That's it. So it will be called ethanol. We will practice the naming somehow. Then we have aldehyde group where two H's are replaced. Okay, one oxygen is being added. Then we have ketone group where again two hydrogens of a mediocre carbon. It is not the end one, बीच में वाला जो carbon है, that is used. And then we have carboxylic acid, COOH, where all the H's of the last C, the end वाला C है, उससे सारे हाइड्रोजन निकाल के उसमें OOH ऐड कर देते हैं. ठीक है. इन अ वे यू कैन से दैट मीथेन, मतलब एक H निकाल के हम COOH ऐड कर रहे हैं. So if it is added to methane, it will become ethanoic acid because अब उसके पास 2 carbons हो गए हैं. Okay, that's all for this chapter. Rest other portion is all deleted.